In this video, we are going to talk about resolution of vectors in three dimensions. Okay, so I have drawn a vector p bar which is in three dimensions. So in the previous video, we talked about the vector which only had two components, but in this case, this vector is not in this plane, yz plane, but rather it is little bit coming outside of that plane as well. So there is a x-axis to carry that component. Okay, now look at this vector p bar, right? The p bar, this is a parallelepiped. Okay, this is a parallelepiped, rectangular parallelepiped, and this is the tail of the vector which is at the origin, and the head of the vector is at this vertex, right? So this you can say is a body diagonal, right? This is a body diagonal from one corner to another corner passing through the center of the parallelepiped. Now we have to find out the magnitude of this vector p bar in terms of its components. Now let's say this vector p bar makes an angle alpha with respect to the x-axis, beta with respect to the y-axis, and gamma with respect to the z-axis. Now as you know, the projection or the component along that particular direction is going to be px is equal to p cos alpha, p times the magnitude times the cos of that angle. Along the y we will have p cos beta, and along the z we will have p cos gamma. So these are the components of these vectors, right? Okay, now this p bar vector can be written as this vector. So I will draw this vector like this, OF, and this is FE. So I can write this p bar vector as OF bar vector plus FE bar vector. OF bar plus FE bar. I can write it like this. Okay, let me check if it is visible. Yes. No. Okay. Now again, this OF bar vector can be written as OA bar vector plus AF bar vector. So I can write it again as OA bar plus AF bar vector plus FE bar vector. Now what is OA bar vector? See, OA bar vector is nothing but the component of P along the x direction, which is P cos alpha. So this is the component along x direction, right? OA is going to be P cos alpha. So I can write this as P bar is equal to OA bar is P cos alpha, which is nothing but Px. And since it is in I direction, I can write it as I cap plus P bar AF bar, sorry. So what is AF bar? Where is AF bar? Okay, AF bar is this, but AF bar is going to be equal to OG bar, and OG bar is nothing but the component of this vector along the y direction. So that is going to be P cos beta. So that is P cos y Py j cap. Similarly, Fe bar is this vector, but the Fe bar vector is nothing but same as OC bar vector, which is nothing but the shadow of this P bar vector along the z axis, which is nothing but P cos gamma. And P cos gamma is Pz, so I can write this as Pz k cap. So you can see the vector can be written in terms of I cap, j cap, and k cap components, x, y, z components. So any vector in three dimensions can be written in terms of I cap, j cap, and k cap. So this is the resolution of vector in three dimensions. Now, what is the magnitude of this vector? It is, let's say, p, and this cos alpha, cos beta, and cos gamma are the cosines. These cosines, cos alpha, cos beta, cos gamma, are called direction cosines of the vector. Now let's see the magnitude of this vector. See, the magnitude of this vector p bar magnitude, let's say it is p, right? So I can write it in this triangle. I can say this is a 90-degree angle. So 90-degree angle, so that's why I can write p square here is equal to Fe square plus OF square. Fe square plus OF square, right? But Fe is nothing but the Pz, so I can write Pz square plus OF square. But what is OF square? OF square can be written as OA square plus AF square. OA square plus AF square, but AF is equal to OG, so I can write it as OA square plus OG square. OA square plus OG square. Now look here, PZ square, and this is OA, but OA is what? P cos alpha. P cos alpha is OA. That means PX square, and OG is nothing but this one, which is P cos beta. That means PY square. So I can write the magnitude of this vector P to be equal to square root of Px square plus Py square plus Pz square. So this will be the magnitude of the vector P. So same like the two-dimensional case. Two-dimensional case only involve Px square plus Py square. But in three-dimensional case, you just add one more component square, that is Pz square, right? So this is the magnitude of the vector. This is the magnitude of the vector. This is the vector in terms of I cap, j cap, and k cap. Fully resolved vector. And one more thing that I want to talk about is the relationship between the direction cosines. So as I told earlier, cos alpha, cos beta, cos gamma are called direction cosines of this vector. So now I can see from here, if I put this value, if I square this on both sides, I will get P square is equal to, is it visible? Yes, it's visible. So I can write P square is equal to Px square plus Py square plus Pz square. But P square is as it is. Px is what? P cos alpha. So I can write P square cos square alpha plus P square cos square beta plus P square cos square gamma. Now I can divide both the side by P square. So I will cancel it, and this will be 1 equal to cos square alpha plus cos square beta plus cos square gamma. So this is the relationship between the direction cosines of the vector. Yeah.